really build a low-cost solution to have your blocks verified and sequenced on Bitcoin with the power of ZKP. So essentially, all of the transactions that you make on an L2O powered layer 2 are verified, or in this case, rolled up into a single zero knowledge proof. So if you verify that proof, you can verify all the transactions in a participating L2O chain's block. And if we could somehow verify that proof on Bitcoin itself and also sequence those proofs on Bitcoin itself, then we could give that chain the same security as Bitcoin. Because if Bitcoin verifies the proof, that's equivalent to, or mathematically equivalent to Bitcoin verifying all of your transactions, right? And, our L2O power layer 2s really unlock a new era of decentralized computing, because, for the first time, you can build these essentially unlimitedly complex applications, since, of course, if you want to have a ZK circuit with 1,000,000 constraints or 1,000,000,000 constraints, we can actually compress that into a single Groth-16 proof, which is of constant size. And we can combine all that computing power with $900 billion of Bitcoin liquidity. So you can build DeFi, you can build staking, you can build earning, whatever you want on Bitcoin using L2O without any security compromises, right? And of course, it also allows us to bring over those existing dApps that some of us may like on Ethereum over to BTC. And we're a VM agnostic standards consortium, so any ZK application or VM works. It can be ported in minutes from Ethereum over to Bitcoin and have first-party support for cross-chain interoperability. So the way that we do that is we maintain a state tree of all of the different L2O chain state root. So if I want to prove some information about the state of one of the L2O blockchains, I can use a Merkle proof to do so on my L2O, and then that super chain root, state root with the tree with all the other L2O states and the leaves, that root is passed as a public input to your proof, so your proof can know about the state of every other L2O chain fully trustlessly. But yeah, so it's very easy, one-click solution for layer 2s, ZK layer 2s only, to be deployed on BTC. We have a couple ordinal operations that accomplish this. So block operation submits the result of a block proof. Deploys a new layer 2 blockchain on Bitcoin. And essentially what you're doing when you do the deploy operation is you specify the verifier data for a zero knowledge circuit. For those that are maybe uninitiated to ZK, please bear with me. We'll be getting to some non-ZK stuff in a little, but I hope we have some ZK folks in the chat. But yeah, so we have a bunch of supported hash functions. So whatever proving backend you work with, you should be good to go. It should be very easy for you to also enable cross-chain operations with other different layer 2s. Currently, we only support Groth-16 BN128, but if you're using a different proving system, you can just do a recursive verification of whatever proof type you like in a Groth-16 proof and then submit that Groth-16 proof. So no problem there. We just selected right now Groth-16 only just because it is the smallest proof size and it's the easiest to verify. And then, as I mentioned, we have a super chain state that just makes it super easy for you to do cross-chain transactions from any ZK-L2 to another ZK-L2 on Bitcoin. It also has native support for trustless transfers of BRC20 tokens back and forth from Bitcoin L2s that are using L2O. Which means that we can also reduce the amount of spam on the Bitcoin network, reduce the amount of cost that people are now paying on Bitcoin. People are starting to complain about ordinals. We can compress hundreds of thousands, if not millions, of those BRC20 transactions into a single succinct 320 byte L2OA proof that's posted on Bitcoin, which is nice. So this is just a look at some of the operations that I was mentioning for ordinals. You can bring them to layer 2. You can transact there. You can reduce the spam. And if you really want to spam the network, of course, you can always transfer them back to layer 1. So you first deploy your L2 ordinal, which is just containing your verifier data, some selections about what proof backend you want to use, what hashes your protocol use for its state tree. And then we have a deposit tree that's maintained by an indexer. So the idea here being that this is kind of like the last indexer you'll ever have to install to your Bitcoin node, because you can make any Turing complete protocol into a zero knowledge circuit and then just use an L2O supported Bitcoin node to index it, and you don't have to like make a new indexer or plugin every time we have a new like Bitcoin application or a Bitcoin standard coming online. And then, of course, we submit our succinct zero-knowledge state transition proofs, which are verified by an indexer. And then we have a withdrawals tree that's maintained by the layer 2, and users can create an ordinal transaction that includes a Merkle proof when they want to go ahead and withdraw their tokens back up to layer 1. But yeah, so main idea, again, we want to unite the Bitcoin execution layer. We've got some great partners that are coming on board, many more to be announced. And that's kind of L2O. But let's say you don't want to build a protocol. You just want to build scalable applications on top of Bitcoin. Well, have I the solution for you? QED. So as I mentioned at the beginning of the presentation, I am the founder and CEO of QED. And QED is a Palladium L2 on Bitcoin that has Web2 UX scale and Web3 security. We have shared global state, just like Ethereum. We support multiple different ZK VMs, and we're horizontally scalable. So we've tested on AWS with hundreds of thousands of user operations per second, but we can do more. Everything is proved end-to-end with recursive zero knowledge proofs. So there's like no security trade-offs. We have O-log and block times. It's really great. And to top it off, we support the world's most popular programming languages. So if you want to build on Bitcoin, build on QED, write your applications in JavaScript, TypeScript, or Python, and yeah, it makes it very nice, even for the Web2 folks to onboard to blockchain. So, as I was saying, like, it's very fast to build on QED. QED has end-to-end trustless succinct verification. So you have the same security as Bitcoin, but you can build complex applications. This is enabled using recursive zero-knowledge proofs. So basically verifying a proof within a proof within a proof. Maybe in a future talk, we can, if there's interest, we can also talk about how we achieve some of the things that we do on QED with ZKP. But maybe it's a good time here to stop and take questions. I think it's been like roughly an hour. So yeah, I'm happy to do any questions as we wind down. But yeah. Any questions?
Folks, feel free to ask any questions. You can unmute yourself right now and ask a question to Carter right away. We'll give about 5 seconds. If there aren't any questions, we can move ahead.
Any questions?
Let me see if there's any question in chat. Hi, Soham. Any questions? There was one. I'm sending it the copy to you on the chat itself. This was a while ago, by the way.
So BASM compiles to normal Bitcoin script. So if maybe I'll share my screen, we can do a quick show off of that. So in fact, I can take the JavaScript as well and compile it. But let's go over here to, I don't know, our reverse example in BASM. So we can see over here in BitIDE that we have this BASM script. And if I click run, it runs it, right? But we also have this window that says compiled result, right? So if we open up that compiled result, this is the actual Bitcoin script for that BASM. So if I put in, I don't know, over here, if we had our reverse, should be, yeah, reverse. Let's say I want to multiply B times A. So I do the op mul, I don't know, mul U8, right? And then I run it and it's going to be 2. Well, let's make this a little bit more interesting. We can make this like 77, right? And it's 154, right? Well, if I want to look at the compiled result of that script, we have it over here. So we can copy it, we can download it. This is what actually runs on Bitcoin, right? So yeah, so we compile our flavor of Bitcoin assembly to standard Bitcoin assembly, and that's what runs on Bitcoin. Now, for example, like over here with Fibonacci, if we click run, we can also get the compiled result of that as well. So we can compile either BASM or BASM or JavaScript to normal Bitcoin script. So that's a great question. And I hope that answers it. Any other questions? I know it has been a lot to digest. I apologize for talking for the whole hour. I should have taken questions earlier.
It's fine. I think if there are any other questions, we'll definitely reach out to you by Discord,
Absolutely.
because I've asked them to collect the questions and put it on Discord server. So once I get it, I'll send it across to you via meeting.
Okay, cool. And I guess just to kind of close out, we also have a Bitcoin talk thread if there's any like feature requests, or we actually came across one bug throughout our presentation today, which is when a transaction fails, it should have an error message instead of showing a success message, which is the error message in it. If you find any other bugs, our Bitcoin talk thread, if you like open up BitID, it has a link there too. Please submit them there, or message us on Twitter. BitID is constantly evolving, so bugs are to be expected, but we've gotten most of them out of the way. So yeah. If there's no other
And
questions, then maybe we can leave it there.
sure, but the community would love to get some of the resources as well. So if you have any other resources as well that you can share, that we can share with the community folks, that will be amazing.
For sure. So like I guess the first thing is if you go to ide.qedprotocol.com, it has like a bunch of links to like setting up how to do scripting step by step over there. Also has like local testnet set up, and of course our Bitcoin support thread there. So I guess that would be the best place to learn more about BitIDE. For L2O, you can just head over to l2o.io. And if we zoom that out a little bit, we have like all the documentation for the full spec of how a block is verified and so on and so forth, and it goes into more details there. And of course for QED, we have our wonderful QEDprotocol.com, and we have the QED blog, which goes into like a lot of the math and how everything works there with the ZK end. So I'll post those in the chat. Oops.
There's
Everyone.
another question in chat, by the way.
Sure thing. What is the first application we can think of and start to build on Bitcoin? Any correlation with scalability? So I guess it depends on the nature of the application, right? So if the application is something simple, like I want to lock up these Bitcoins for this period of time, then you can just rely on Bitcoin's existing scalability. If you want to make something more like trading, then you're going to want something that's more scalable than Bitcoin itself, just because of the cost of Bitcoin transactions. So if you want to build something like trading, I'd recommend building a DEX on QED. Or if you want to build your own like protocol or your own ZK application, you can just use L2O to do it, and then have people basically deposit their assets in via the L2O supported bridge, and then when they're done trading, withdraw them out. Bitcoin itself is not particularly scalable and has very long block times, and has very expensive transactions. But as we've mentioned, $900 billion of liquidity is also nice, right? It's worth it to put up with Bitcoin's flaws, such as not having multiplication. But yeah, so it really depends on the application and intended audience. But yeah, I think Bitcoin script is going to be an evolving landscape as well. There's lots of new efforts to enable things like opcat, which lets you take two stack items and concatenate them together. But yeah, let me post some resources. So we have for L2O, L2O.io. That should be HTTPS rather. And then of course HTTPS, we've got our protocol.com. And then for QEDprotocol.com/blog, paste in this link here, you can learn all about how ZK on QED works. But yeah, it's so nice to have this opportunity to talk to the community. We're very, very appreciative, and we'd love to come back on again if people want to learn more about ZK, lots of topics. We've got a solid team of like 30 guys, so we're working on a lot of stuff at the same time. We always love to share, and appreciate everyone for taking the time to listen to today's presentation.
Awesome. Thank you so much, Carter. I'm sure the community is thrilled, and we will need more sessions from you for sure. 100%. We've been doing this. We've been planning a lot of sessions with respect to ZKs as well. So further down the line, I'm sure we're gonna have to see you again. Thank you so much for this session. If you have any question, guys, make sure you put it on Discord. I'll try to make sure that all the questions are sent to Carter and being answered. With respect to the resources, everyone will get all the resources on Discord server itself. So I've taken the note of that as well. Thank you so much, Carter. Ladies and gentlemen, this is N and we're signing off. So thank you so much for joining in.
Thanks so much for having me. Take care, guys.
All right, guys. Have a good one.